Hello everyone, and welcome back to solving difficult questions. Let's see what is today's question. And it's medium and average acceptance 4. So we have two numbers. X has the same number of set bits as number 2 and the value X or XOR num2 is minimal. So we have two numbers. So XOR will produce one, I think, if the bits are different. So XOR equals 1. Let me check. So, if it is, yeah, so if they are different. So we have to find number of bits from num2. We can find it by subtracting powers of 2. Subtract power of 2 from num2 until 0, right? Then we have to find go from greatest go bit by bit over num1 from greatest to lowest, and if bit is set, use one of the one. If it is set, we will destroy this bit with 1 from our stack of bits. If not, keep this bit. If at the end we have some bits left, convert it to minimal number. For example, if we have one bit left, we will have number 1. If we will have and some bits in the stash left, we will convert it to the minimum number. If and extract number from num1 and extract number from num1 if and num1 greater than 0, return num1. Yeah, something like that. Right? Did I get it right? So first we will count number of bits. So while num2 is greater than 0, int stash equals 0, int pow2 equals 0, and we have to start from greatest. Sorry, I have to start from the greatest. While num2 is greater than power 2, power of 2 plus plus. We can just do power plus plus just to not have so this way we will find the power of 2, which is next. So power of 2 minus minus. So while num2 is greater than 0, we will set num to mass power of 2 if temp is greater than less or equals to num2, we will subtract it from and we will save increment stash. If it is not, so if at some point we have power of 2 greater than num2, that means we have a 0. We will not increment stash. The first part is done. We have number of ones to use. Int power 1 equals 0. Let's find max power. Power 1, power 1, power 1, power 1. Power 1 minus minus. We found maximum power. So we have to go the same way about the one. Power 1, and if temp is so if we have we will decrement. If we have 1 here, we will destroy it. Yes. And if num1 is greater than 0, return num1. If stash is greater than 0, create num, else return 0. So while we will return num1, and while stash is greater than 0, we will do num1 plus equals math power of 2 dash minus minus. Minus minus and dash, because we have number of ones, so it should be greater than 0, but we will use index of this dash number, 0 based. I'm not sure if it will work, but let's see. We don't need this condition probably, but yeah, anyway. There shouldn't be a lossy conversion. What do we have here? We use long. It doesn't matter much. I know. Time limit exceeds. So we have infinite loop somewhere. Mm. It means this if we don't need this condition. Okay. I have stash set to 0. There is no ones. We have power set to 0 until we not found max power greater than nums. So it should be in this example num2. It should be 2 power of 0 is sorry, 2 power of 0 is 1, 2 power of 2 is 4, 2 power of 3 is 8, and 8 is greater than nums2, so we will have here let's check. We have here 3, so no, 1, 2 power of 0 is 1, 2 power of 1 is 2, 2 power of 3 is 8. So we have 8 here, and we are decrementing power of 2, and we have 2 here. So until number of num2 is greater than 0, we will calculate the next power of 2. So power of 2, 2 power of 2 will be 4. And temp is less than number of 2. We will subtract 4 from number of 2, and we will increment stash. Then power of we can decrement it here. I found it. Now we should go. Time limit exceeded. Okay, for 12 it will be 16 and it will be, so 3 is 8, 4 is 16. 16 is too much, so it will be 3 here. So num2 is greater than 0. We will go here and it will be 8. 8 is less than 12, so 12 minus 8 it will be 4. It will be stored here, so we will go next and it will be 2 power of 2 and it will be equal to num2. We will subtract it and num2 will become 0 and stash will be incremented. We will go here, it will be 0. We should have 2 ones in the stash. We will go here and we will check. So power 0 is 1 and so we will not increment. Yes, it should be like that. Greater or equal to. So for 0 it will be equal. We will increment it. We will go to the next and it will 2 power of 1. It will be 2 and it is greater than num1. So we will skip this part and we will decrement our power back. and then we will go through our cycle once. So it is power of power of 0 is 1, temp is equal to 1, so num will be 1 will be subtracted from num1, which is 1, and stash will be decremented. Then we will go here, stash is not less than 0. Stash is greater than 0. So num will be incremented by stash is 1. So it will be incremented by power of 0. And it will be 1. Let's try again. We couldn't use this trick because we can have set bits here. Exactly like that. So we have to use two stashes here. So it's 1, 2, 1, 2, 3. So we can check if the number have same number of bits. I will not rewrite this part, but I will rewrite this part. This one. We can keep this part. So we found max basically if we have stash which is greater than power of max power plus 1, greater or equal to max power plus 1. The best way to use this stash is to just there is no other way. We have to create we have to use all these ones. So if stash is greater than path1, return all ones stash, else. So if we have more like ones and zeros in the number than in the stash. For example, we have 1 in the stash and we have number like this one, 12. Best way is to destroy greatest. Yes, destroy greatest until there is no more. So result plus equals Let's see what is the performance. Wrong answer. Expected. So in 72, it is what? 3 is 8, 4 is 16, 5 is 32, 6 is 64, so it will be 164, and another one is 8, so 2 ones, and for 25 it's 16 plus what, 9 is so 8 and 1. Yes, we should use 2. But we have used 3 once. Let's go through the code. So we have 72. Power is 4, 4, 5, 6, 7, 6. So it will be 6. Temp will be 64. Temp is less than number. Num2, 64 minus stash is 1. Go back. 32 is here 32 is not good. We're skipping this if. 16 is not good. We are skipping this loop. 8 is good. We are incrementing stash. And exiting here. So looks like we are using it properly. So we have 2 in the stash. Calculate power. So we're going 4, 5, and back to 4. So here will be 4. Result is 0. Num1 is greater than 0. Stash is 2. And it is less than, what do we have here? 4. 2 is less than 4. So we're going here will be power of 4 and it is less than 25, so result will be 16. Stash will become 1, number will be 9. Number is greater than 0, 9. Stash is 1, which is less than power of less than 3. So we're going here. It's 8, 8 is less than 9. Result will be 24, stash will be 0, num will be okay. And stash is greater than 0. This way we will break this cycle when we don't have more ones. So yeah, run. Yes, and submit. Yay! But we are slower than best of the best solution. Let's try to submit it again, maybe we can squeeze something. No. So yeah, probably it should be not like cycles, but not like mass power, but something a little bit more elegant. But I'm satisfied with this solution. It's good enough. Good memory usage. Okay, see you tomorrow.